Hello students, in this video we will solve a numerical based on conversion of electrical energy into mechanical energy. So let's read the numerical firstly. A pump driven by a DC electric motor lifts 1.5 meter cube of water per minute to a height of 40 meter. The pump has an efficiency of 90% and the motor has an efficiency of 85%. Determine power input to the motor and the current taken by the motor from a 480 volt supply. Assume mass of 1 meter cube of water is 1000 kg. So conceptually one should firstly understand what is happening in this numerical. So let us consider let us correlate this with some real life example. So we all have seen pumps operating at our home, at our farms, which lift water from some well or some bore, and we use that water for different purpose. Now one such pump is being driven by a DC electric motor in this case. So here amount of water being lifted by the pump is given, and to what height it is being lifted is also mentioned. So, and in this case we have to find out what electrical power input should be given to the motor for this process to take place, and then what amount of current this motor will require from a 480 volt supply. So let's start identifying the things given in the numerical. So things given are mass of the water being lifted is 1500 kg per minute, and all the calculations will be for a minute, so we need not mention it per minute. Height to which water is being lifted, h is equal to 40 meter, and efficiency of pump is 0.9 and efficiency of motor denoted by eta m is 0.85. Voltage across which this motor will be connected is 480 volt. Now firstly we will focus on calculating power input to the motor. So before we calculate power input to the motor, here a process taking place in this case should be understood. So look at this. Input electrical energy will be given to DC motor. So DC motor operates on electrical energy. Output of DC motor will run the pump, and output of pump is actually work done to lift the water. So when pump is lifting the water, output energy from the pump is actually getting delivered to the water that is lifted. So the water that is lifted will store output energy from the pump with itself in the form of potential energy of the water. So potential energy of the water, lifted water, is actually equal to output energy of the pump. So if we understand this, we can now calculate output energy of the pump. So as I said, output energy of the pump is actually work done by the pump, and work done by the pump is the energy that is stored by the lifted water on the virtue of its position, that is in the form of potential energy. So we can use this formula m into G into H to calculate the potential energy with the water, and we can substitute the values identified in the given to know what is the output energy of the pump. Here in this case it is, firstly we will find out the input energy to motor based on the output energy of the pump. So it can be done in this fashion. Input energy to motor is input energy is equal to output energy divided by efficiency involved in the process. Now see, there are two equipment involved in the process. One is pump and the other is DC motor. So when process comprises of 2 or 3 appliances, then efficiency of the whole process is multiplication of individual efficiencies of the individual equipment. So here in this case, eta m is efficiency of motor and eta p is efficiency of the pump. So efficiency of the process will be eta m into eta p. So if we substitute the values identified so far and the values calculated for output energy of the pump, what we get is input energy required to motor is 7,69,411.764 joule. So these many joules are being given as input energy to motor, and if we divide these joules by the time required for this process, we get the power requirement or input power to the motor. So what I did, look at this, it is the input energy divided by the time. So time was, it can be seen, it is per minute, the process is happening for a minute and hence 60 seconds. So what I get is 12.823 kilowatt is the input power in the form of electrical power that is required to run the motor. So if I want current that is being taken by the motor to be found out, I can use this power and divide it by voltage. So look at this, input power to motor divided by supply voltage can give me current taken by the motor. We know the formula for power in case of DC supply, it is P is equal to VI. So I am finding I should divide P by V. So power was already calculated over here. I substituted it in the numerator. Voltage as was identified in the given, it is 480 volt. So ultimately I get this requires 0.02671 into 10 raised to 3 ampere. So ultimately I mean 26.71 ampere of current is required for this motor to run to carry out the process when connected across 480 volt supply. I hope this numerical is understood.